Hello dear students and parents. So let me tell you one very important thing. This session is going to be a game-changing session for all of you in terms of the chemistry. Now, each of the students watching this session, let me tell you that please attend this session with your parents in order to have an understanding that how the student can learn in the best way possible. Okay? So here, let me start with my introduction. Well, you are meeting Sush ma'am. My name is Sushmita Singh and I have done my bachelor's from RI NCERT. Also, I have done my master's and tried bagging the silver medal. So, of course, you are here, and if you feel any type of question after this session, you can definitely connect with me or your personal teacher. So, here I will be just going with a very short question, and you feel that this is the advanced level question. Definitely, yes. Now, after this session, you will be able to solve this question on your own, and that is my belief. So everyone, please ensure that for another 15 to 20 minutes, you are totally focused toward the session, and please challenge yourself that you can solve this question. Okay, so let us go ahead with. So here a very literal question that is related to your real life. Now you might have come across the lemon, baking soda and oranges. Could you just tell me the taste of these items? Could you just tell me the taste of these items? Yes? Just try to tell me the taste. So I believe that here we have what kind of taste? For the lemon, we have sour taste, right? If we talk about the baking soda, what would be the taste? So the taste would be bitter, right? And if we talk about the orange, right? What would be the taste? For the orange, it tastes like sour come sweet. So we can say sour. Also, you feel sometimes sweet when it gets ripens, right? So here we can see that some of the item taste sour and some of the item taste bitter. So if I ask you some question related to acid and base, what you have the pre-existing knowledge? Let me go through it. So here, if I just talk about this, okay? So here, let me tell you one very important thing. That whenever you come across this question, what would be your significance of knowing the answer? All acid tastes sour while all bases taste bitter. Is it so? Is it so? What would be your answer? Just have a guess. Just use your concept and tell me that all acid tastes sour while all bases taste bitter. Is it so? Okay. We will be having a revealing answer for this after we spend our time in understanding the clear concept. Okay. So let me just go through it. If you have any analysis, could you just answer me? According to this, coffee is basic in nature? Yes or no? Come on, just have a guess. Okay. Use your concept, whatever you are having till now. Okay. Now, just go through the riddle and you will find something very surprising. Let me read it out for you. Coffee is brown and bitter in taste. Is it an acid or a base? Don't give the answer without any test and you are in the dark with its taste. So here you can find that here one is test and one is taste. Now what is there the difference between both of these words? So here if you are giving the answer with help of the taste of the item, then you are in some kind of miserable state of learning, right? So let me tell you here that bachcho, what you have to understand is very important that you have to look around the surrounding. You will have to go deeper in the concept, and here there is a difference among the taste, but eventually you will come across that where they are having a common point. So let me talk about the coffee. What is the taste of the coffee? Bitter. What is the taste of the tea without sugar? It is also bitter, right? We have the green tea. So that is also bitter. And then we have honey. Ma'am, honey is not bitter in taste. Why it has been clubbed with tea and coffee? Right? It is sweet in taste. But let me tell you, child, that here all of this has some common point. So these all come together and they all are considered that they are having acidic nature. They all are having acidic nature. Yes, my dear student, they all have acidic nature. Now, what is the nature behind this? Okay, what is the reason behind this? So, dear student, if we talk about this, then coffee tastes bitter, so it is basic in nature? No, absolutely no. Why? Let us find out the science behind it. So here, of course, no. Coffee is actually acidic in nature. Yes. And why it is so? Because it contains what kind of acid? And that pertains to give the acidic content to the what? That is the coffee. So here we are having the caffeic acid and the quinic acid that adds the acidity nature to the coffee, and here we can say that it's just not about the taste. Here we also have to look into the components that is pertained in the particular substance, right? I hope that now you have got the idea why did I ask that question, right? So now you can definitely answer this, that does all acids taste sour while all bases taste bitter? Then here I can see that most of you can answer it as false, right? Yes. So the answer is false because all the acid doesn't taste sour. We have got the understanding from the coffee example, right? It has quinic acid, it has caffeic acid, but it does taste bitter. Why so? Because here we are not only justifying the characteristic of the taste here. We also have to look the reason, the scientific reason behind that. Now, coming across the next one here, we go for that if not all acid, then how we are going to just give its property of the acid. So here we have to replace all with generally. We have to replace all with generally, right? So generally acid tastes sour, but yes, there might be instances, there might be the substances which is acidic in nature, but yes, given a chance, it might taste sour, bitter, or it might taste sweet, as you have seen in the case of the honey. Got it? Now, come here, look across these examples. You find that they all, cucumber, baking soda and bitter gourd, they all taste bitter. And here we can combine them as the examples of the base. Now, here you might have observed that soap, which usually you do not taste, but there is some other kind of the property from which we can pertain that what is the nature of this substance. So basically, if you find that cucumber, right, you rub the upper head of the cucumber and you find that it is creating lather or foam. Why so? Here, when you just rub across the soap, you find the foam forming. What is the reason behind that? Wait, let me tell you that here, these all characteristic features are of the base. So yes, if we see the cucumber creating the foam, soap creating the foam, then yes, there is the basic nature of these items. Now, if we come across that, ma'am, you have said that, okay, some items are sour, some items are bitter, and accordingly, we can find some of the other properties also. But here, let me ask you one very important question, that is it wise to taste or touch all the item? If I ask you, just taste the paint and guess that whether it is an acid or a base, would you do it? If I ask you that, yes, take any type of medicine and tell me whether it has an acid or a base. If I ask you that car battery is there, okay, so there is some liquid, please taste it and tell me that whether it is an acid or a base, would you be able to? Would you be able to if I ask you that bleaching powder, taste the bleaching powder and have a guess that whether it is an acid or a base? Probably I won't be doing this. Would you do it? Would you do it? Possibly no one is going to do it, right? Then what? How we are going to get the nature of these substances, right? So, to identify that a substance is an acid or a base, tasting or touching the items or the substances is really wanted or really possible, that we can taste every other item, we can touch every other item and we find that yes, it is an acid or a base. No, no, absolutely no, right? It would be false. Then what, ma'am? Right? Of course, many would be thinking that, ma'am, then what we do? But Che, if you see that here, we are putting a spoon, right? We are putting up a spoon here in the liquid. Now, I don't know that what kind of a liquid it is. It is quite dangerous. I'm not going to touch, right? I'm not going to insert my finger over there, right? And you can possibly see that the spoon, it is losing its entire component, right? So here we have to understand that it can be dangerous, quite dangerous, right? So here, what is the next possibility that we have to understand? So how do we find that whether a substance is an acid or a base? Let me tell you that now. Perhaps you might have had a guess here. Yes, of course, with the help of the indicators. Now, what is that universal indicator if you have come across this? How many of you have come across the indicators? Indicators are the type of the chemicals used to identify whether a substance is an acid, base or neutral. So these type of chemicals can get you to identify whether any of the substances acid, base or neutral. Now, how many of you have come across this? Just have a guess. You might have come across this so far. Okay, so what it is actually, it is the universal indicator and it has been gifted to us by a Danish chemist, Dr. Søren Sørensen. So yes, this is the pH scale. Let me write it for you. So this is the pH scale. Now what is this pH scale, right? What is this pH scale? Please just focus on the notation also, how I am writing the pH. Now let me go for the further one. So yes, this is the pH scale. You might have come across this and why it has been named. So what is the meaning of pH? Very important. And I will tell you that if you ask to any of the student, right, probably you can just keep a kind of a question for your peer group. And let me tell you, if you are having the partial knowledge, you won't be knowing that what is pH. You might know that yes, there is some word pH existing, but you're not knowing the meaning of the pH. So this is where we have to find the great impact that you are learning the things in a very deep conceptual manner. So we have to understand that what does pH mean. So pH, P has been derived from the word potens. In German, it is actually potential. And when you come across the H, most of you have had that yes, H is the symbol of hydrogen, the very first element of the periodic table. So yes, this is all related to the hydrogen element. Now we will find the reason also, of course. I'm not going to keep you in any kind of dark that yes, you only know the superficial knowledge. We have to go deep and have the conceptual knowledge. We will understand this. Now, as I always say to my student that your focus, your concentration should be there whenever the teacher is teaching you, because they are transacting the knowledge in a very, like a complete way where you have to observe, you have to focus, and this is going to definitely help in your developing the concentration and logical thinking. So can you tell me which of these is the correct way, correct notation of writing pH? Correct. So what it would be? It would be this way, P raised to the H. Now here we can see that if we are having the next one, that is the universal indicator, what it is actually just talking about. So here you can see the shades of the color, right? So if we talk about the value that is there in the pH scale, so it is actually a scale, right? And scale does have number. So if you see, it starts from 0 and it ends up to 14. Now there is also a big reason behind that, why it only refers from 0 to 14, why not 15? So this is also what we need to talk about. Now, if we see that, what is the range of this universal indicator? That is from 0 to 14. Now, you can see that there is a mid value. Can you find the mid value? If you calculate from 0 to 14, could you please find the mid value? You will probably come to 7th. So now, it is completely here. If you come for 7th, right? And if you go for the left, right? So here you are watching this and you go for the left, you will find that these all pH value is indicating that a substance is acidic. And if you go for the right, it means that it is indicating that the substance pH value is more than 7. And perhaps it would be basic. So we come to this that if any of the substances having the pH value lesser than 7, it would be acidic. More than 7, it would be basic. And what about 7? If it is 7, it would be neutral. I hope that you are up to this. So here we can see that when it is moving into the left side of yours and when it is moving towards the left of the 7, you find that the value gives for the acidic substance. Whereas when it moves for the right of the 7, it gives a value for the basic substance. Right? Now here, if the pH value is equal to 7, it is neutral. If it is more than 7, it is basic, and if it is lesser than 7, it would be acidic. Right? Good to go. Now, here there is a comparative value. You can see that pH is equal to 6.5 and pH is equal to 8 of the almond. So, which of these is an acid? Which of these contains acidic nature? What would be the answer? Yes, of course, the one which is having the pH value lesser than 7. What about this? Which one is a basic item? The pH value with 9 or the pH value with 3? Of course, the pH value with the 9, which is having more than 7. Now here, when we go for the next one, we find that there is baking soda and there is what? There is the vinegar, right? What kind of value is, like, what is the difference between the value? You can see that pH is equal to 9 for the baking soda and pH is equal to 3 for the vinegar. So, of course, which one is an acid? The one which is having the pH value of 3 and the one which is having the pH value more than 7. That is probably 9. And here we get to know that the one which is having more than 7 would be basic. What about this? Right? Which one is an acid? Which one is a base? So let me tell you here, pH 0 and pH 4. Which of these is an acid? Let me tell you that both of the values are lesser than 7, then both of them are actually having acid. Right? So you have got the conceptual understanding. And now here, we all believe that if we go according to the logical approach, we go according to the critical thinking and of course the visualization, it is going to give you the best of the scientific learning, and this is what we pertain to and the ODA vision, and of course I stand by this. Okay. So here we all have come across the pH scale, but what is the scientific reason behind this? So do you want to know the chemistry behind the pH scale? Let me reveal it. So just take an example which is in your surrounding, which is in your body. Let us take the example of the acid present in our stomach. What is that? It is the HCl. What it is? It is the HCl, that is hydrochloric acid. Now, if you come across the hydrochloric acid and when it is dissolved in the water, it is going to release the hydrogen ion and it will ionize to give the hydrogen ion and the chloride ion. And do you remember? I have said you that somewhere I am going to just reveal that how the pH is related to the hydrogen, and here the rule comes up, right? So here if we take the HCl, it is going to ionize and give the hydrogen ion and the chlorine ion. Now you can see that this is the hydrogen ion and it is related to the scale, right? So now as we are talking about the H plus ion, right? So here you can relatively see that this scale is also related to the pH scale. Now you can see that the mid value, as I have also scaled here. So when we move towards the left and when we move towards the right, there is the difference in between the hydrogen ion concentration. So if you see that which part of the scale has more of the H plus ion, so it is very, very reflective that it is the left side, right? So it is the left side which is having more of the H plus ion and it is very relatable to the pH scale. So here I have taken the hydrogen scale also and here we have taken the pH scale also. So hydrogen, more of the hydrogen ion. If, for example, let us take as HCl, right? As we have taken just right now, HCl. So how much hydrogen ion it is ionizing, right? How much hydrogen ion is being released when it is dissolved in the water. So if it is producing more of the hydrogen ion, then definitely it is going to be more acidic as compared to the other values, right? If we come across the base, we can find that it has relatively very less production of the H plus ion, which is probably altered by the OH minus ion. Now yes, if you have less value of the pH, less pH value, then definitely more of the hydrogen ion is there. So if we take the example of the 0, 0 is having the maximum number of hydrogen ion, and yes, you can see that among 0 to 6, which is the lesser pH value, of course 0. So here we have less pH value, means more of the hydrogen ion and more acidic it would be, right? So yes, I'm having a quiz for all of you, and equally we will be having a lot of quizzes in the session. So here I have a question based on Dr. Sorensen observation. Which of the following correctly identifies the scientific notation he should use to represent the acidity or alkalinity, the basicity of the solution? Which one it would be? You can just let me know, and probably you have guessed by now, right? So similarly, we will be having more such kind of effective quizzes. And here is one question for all of you to understand that the topic from where we have started and where we are ending is all what is related to your real life, right? So here, please find out the pH value of the blood, and do let me know that what would be it and what would be the nature of the blood, whether it is going to be acid or basic, right? So yes, I'm going to see you there in the master program and waiting for all of you, okay? So thank you so much for being here. Thank you for your presence. Let me see you there directly in the master program. Bye-bye everyone.